One is going to be speed that is basically represented by v, and it is defined as total distance over total time. So if we define it in terms of, description, so speed is defined as rate of change of distance, or in simple terms, this would be distance traveled over time. Units are meters per second. And one of the important conversions is going to be, discussed here. In many times, in many cases, the examiner don't use this meters per second. They basically use kilometers per hour. So we need to know how to convert from kilometers to meters. So that's by multiplying it with 1,000, and from hours to seconds, that's by multiplying with 3,600. So if we have something like, say 100 kilometers per hour. So it is recommended to convert it into meters per second. And how do we do this? We have to multiply 100 with 1,000. So this gives kilometers to meters. Then there is a denominator here. So we have to have a denominator here, then hours to seconds. So then 3,600. So this is going to give us meters per second. That's speed. Again, very important thing is speed is only a scalar concept. So we don't have to know the direction. So since it is a scalar concept, so there is nothing related to direction. Essentially, these questions which ask us to calculate speed are almost negligible. But what is, asked in the questions is relative to graphs, motion graphs, speed time graphs and all. So we are going to go through those as well. But, for now, what we need to know is, okay, what is speed? That's distance over time. What is the representation of speed? That's v. What's the unit? That's meters per second, and there is a usual conversion between meters per second and kilometers per hour. So we need to know that as well. So is this understood till here now?
Yes.
Nice. Acha. The other thing that's related to speed, or that's kind of similar to speed, is velocity. But there is a very big difference in this. So if I add a direction with speed, so the quantity itself becomes a vector quantity and it becomes velocity. So for example, if I say there is a car that travels at 100 meters per second. So what you don't see is, where is it traveling at? Is it going north? Is it going south? Is it going east? Is it going west? You don't see that. The only thing you see that is there is a car that is moving at 100 meters per second. So it's like, if you just imagine this, that there is a traffic police management system, and then there is a car that is moving beyond the speed limit. So they are going to issue you a ticket. Okay. And that ticket would not mean, either you were going in emergency or you're going to school or wherever you're going. As long as you're going above the speed limit, you will have to get a ticket. So all these traffic management system programs, they are related to only speeds. They're not related to velocities. They're not related to the conditions of the driver. They're not related to how urgent it is, for you. Maybe you're missing a flight. Maybe there is some emergency going on. So they don't care about it. So if part of the information is given, that's, something is moving fast, something is moving slow, something is moving at this much meters per second. So that's the speed. That's only speed. But if you say, this is related to our direction as well. So a similar case, a plane flies at, 100 kilometers per hour due north. So now what additional information have I given? So I added that this is the speed, right? And I added a direction to it as well. So we often, come across these situations where students struggle with understanding velocity. So velocity basically has two things, A and B. So if you eliminate B, what is left is speed. So velocity is, a kind of speed with a direction. Do you get this part?
Yes.
The other important part is you need to know this as well, that if there is a change in speed. Now, what does that mean? So something was moving with 100 meters per second. It changed to 110 meters per second. So that's, you say that's change in speed. And in physics, this would be represented as u, that's initial speed. This would be represented as v, that's final speed. Okay. So that's change 100 to 110. So change in speed is represented by a triangle and a v symbol. And this would be 110 minus 100. So it is always final minus initial. Okay. So the change in speed would be here 10 meters per second. Okay. That's one thing. Now, let's say there is something like, 10 meters per second, and it becomes, all the way 100 meters per second. So what would be this 10? U. What would be this 100? V. So what's the change in speed? That would be 100 minus 10. And that is still final minus initial. And that's 90 meters per second. That's change in speed. Now, the other thing is, if I say, what is the change in velocities here? So, what would your answer be? Is velocity changing here? So, the answer is yes, velocity is changing. Why is velocity changing? Because velocity has speed in it, right? And it also has a direction. So, either way, these questions, they were not, identifying the direction, but either way, they are identifying speed, and that's what is changing. See, speed is changing from 100 to 110, speed is changing. So, if speed is changing, what will change? Velocity is change. Do you guys get this? So for the same question, if I ask, what's the change in velocity? So change in velocity is 10 meters per second. What's the change in velocity here? That's 90 meters per second. So can I say change in velocity is the same as change in speed? Answer is correct. Yeah, that's fine. But it will only work if velocity changed due to change in speed. Do you guys get this?
Yes.
Now, let's talk about a special criteria where what happens is there is no change in speed, but there is still a change in velocity. Can you, relate to what I'm saying? Can you think? What I said is there a change in velocity possible even if there is no change in speed? So, say there is a car that is moving at 100 meters per second and it continues to move at 100 meters per second. So, you know, is there any change in speed? So the answer is no. It's not. It's the same thing. Initially it was 100, finally it's still 100. So what you see is change in speed is zero, right? But my question is it possible for the same car to have a change in velocity even when the speed is not changing? So think on it. No answers? No problem. So there is a case where such a situation, may be possible. How? So for example, if I say this was, car traveling, say at 100 meters per second due east. So this was 100 meters per second due east, right? And then somewhere here, this car, you know, started to turn and it moved towards north. So now what you see here is, even though the speed is same, right? What has changed? Direction. So let's go back to what we have discussed. What was velocity? Velocity was direction and speed. So we can understand that speed is not changing. But is there any change in direction? The answer is yes. change in direction. It was initially moving towards north and sorry, towards east. Now it is moving towards north. So change in direction, yes, it is. So is there change in velocity? So yes, change in velocity. So even when speed is not changing, velocity can change. Do you guys get this?
Yes.
So one of the best examples for this would be a circular motion. Imagine, right now, motion of Earth. So is Earth moving? Answer is yes. Is Earth moving with change in speed? No, it is not moving with change in speed because we always have 24 hours for one complete, rotation, and we always have 365 days for one complete revolution. Okay, but is it moving in a straight line? So answer is no. It is not moving in a straight line. It is moving in a circular, maybe parabolic, maybe elliptical, maybe, as per modern astronomers, it is moving, neither circular nor parabolic. It may be moving in any circular path in anything. So there is change in velocity even when there is no change in speed. Similarly, if you consider a fan moving right above your head, so is it moving, with faster speed and slowing down? Answer is no. It is not changing its speed, but is it turning? So answer is yes, it is turning. So if it is turning, is there change in velocity? Yes, it is, it is having change in velocity. So every time you encounter a circular motion, every time you encounter any change in direction, maybe not a circular motion, maybe a little bit change in direction, you will always have what? Change in velocity. Do you guys get this?
Yes.
Hello.
Yes, sir, it's there.
Do you want me to repeat it?
No, it's there.
So, so third thing is, you know, a scenario would be if there is change in speed, right? So do we agree that change in speed will have change in velocity? Yes, that's true, right? So second scenario was change in direction. So is it a case when there is change in direction, do we have change in velocity? Answer is yes, we can have that as well. What if both of these changes? We have a change in speed as well. I'm drawing a triangle to show change in speed, and I'm drawing a triangle to, direction. So that means change in speed and change in direction. So is it change in velocity? Answer is yes. So if any of the two changes, the idea is if speed changes, we'll have change in velocity. If direction changes, we'll have change in velocity. If both of them change, then even we'll have still change in velocity. Parisa, do you get this? So it is not about,
Yes.
it is not about that always both of them has to change. No, 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 no. Even one of them has to change, the other will change. So we'll have change in velocity, even if the other is not changing. So let's do a scenario. I want you guys to think and then answer. So there is a ball that moves up at 10 meters per second, right? It reaches its maximum height, say here. That's where it, kind of reaches the maximum height, and then it all the way comes down back, right? So it's 10 meters per second again. So think and then answer. Is this ball having change in speed? You can write your answers in the chat box, so that none of the other candidate can see your answer. If you're okay, you can just, share it on the group and all, whatever you're comfortable. So the answer would be yes or no. Let's see. So the question was there is a ball that went up, reached maximum height, came all the way down. Is it having any change in speed?
Sir, do we need to WhatsApp you the answer?
Sorry, come again. What are you saying?
Are we supposed to WhatsApp you the answer?
You can write it in the Zoom chat, or you can, WhatsApp me the answer, whatever you're okay with. I'm following both of them. So I have my
Actually,
answer. Yeah.
the chat is disabled. I don't have a phone right now to
No,
WhatsApp it.
chat is disabled on the WhatsApp. Oh, I see that.
Zoom chat.
Yeah. Zoom chat is not disabled. Maybe WhatsApp chat is disabled. I need to see how can I.
Sir, the Zoom chat is disabled too.
Zoom chat is also disabled. How? Why? How is this possible? Who did that? So participants can chat with host and co-host. So yeah, you can chat. You can chat. Can you see now?
Yeah.
It was never ever, never ever. So Hadissa, I haven't still received your message. Yeah, got it. Now I got it. So speed changes. Okay. So the correct answer would be that if something goes up and comes down, so speed will change. So there is a change. Now, why is that so? Because once anything goes up and it reaches maximum height, what does that mean? So you have sent something up and it as it moves up, what should happen? Think about it. If you have a ball, just think about it. If you have a ball and you throw it upwards, what happens? Does it continue to move with the same speed again and over and over until it leaves, the planet Earth and, enters the galaxy and enters the Milky Way? No, it is nothing like that. It goes up a few meters, then it has to come to stop, right? And then it will come down. Make sense? Because as it moves up, what we know by default is there is something called gravity, right? And gravity basically wants everything to be, attached to the surface. So if something goes up, gravity is going to pull that down. So that results in a decrease in speed, right? Does this make sense? So ultimately it has to slow down, right? And eventually, as it reached somewhere here, it will stop for a very short interval, for a very short time, and then it will start to fall down, right? Do you guys get this part? Parisa, do you get this?
Yeah.
Sir, but why does the value stay the same? 10 meters per second.
That's the other part. What right now, the upper part of the journey. Does this make sense to you that there is change in speed?
Yes.
Now, let's see, if someone throws a ball and it went up, 2 meters like. So from 10 meters per second, it went to 0 meters per second, right? Let's say it started here and this was zero. Now, we know by default that ball is going to fall the same height. That means if it goes up 2 meters, it is going to fall back 2 meters, right? So eventually, the speed which you used initially to throw this up, it will have exactly same speed at the same height, right? But that doesn't mean there is no change in speed. This was a very tricky question because speed changed as it moved up, it slowed to zero, and then it increased to 10. Do you get this?
Yes, sir.
What about you? Yeah, you have a question. Let's see. Yeah, sure. So say, if imagine you are, there are two, two of your friends, you're playing, say badminton. So the amount of force you use here to, hit a shot would be delivered right till here, right? Make sense, Parisa?
Yes.
So what has happened? What has happened? Just consider one of the things that has happened is your, ball kind of, the shuttle you have here, it went up. Maybe it went up, 1 meter, and then it fall down exactly 1 meter, right? So the amount of speed it had here, the amount of force it had here, if you, hit a very rapid shot, so this would be very difficult for this guy to handle. If you have a very smooth shot, maybe, this would be a friendly match and no one is fighting for scores. So this would be a very smooth, hit here. So the amount of force you initially use is the same as it is delivered on the outer end. You get this? So if it goes up 1 meter, it comes down 1 meter. So the amount of speed it took at the takeoff and it took at the landing would be same, would be exactly same. Make sense?
Yes.
So there is change in speed in this question, even if it ultimately lands with 10 meters per second, because it went from 10 to 0 and then all the way from 0 to 10. So that's change in speed. Now, for the same question, is there change in velocity? What would you guys answer? Is there change in velocity? That's nice. I have one of the answers. So both of the answers. That's nice. So we have change in velocity. That's wonderful. That's great. Now let's add a second, a more complicated part to it. Is this change in velocity due to change in speed, or is this due to change in speed and direction both? So let me reiterate. My question is, this change in velocity, is it due to change in speed only? Or is it due to change in speed as well as direction, or both? That's my question. That's nice. I have one of the answers. Due to both. So you do guys, both of you guys get this part very clearly, that the change in velocity is attributed to speed as well and direction as well, because it goes up and then it comes down. So going up is a different direction, coming down is a different direction. So that's wonderfully done. So whatever this change was, if we divide this change in velocity, now we have established that change in velocity could be due to three reasons, right? This would be because of change in speed. This could be because of change in direction. This could be because of change in speed and direction both. So this change in velocity, if we divide it with time, becomes what? This becomes acceleration. So acceleration is defined as rate of change of velocity. When we say rate of, that means we have to divide this with time. So the mathematical notation for this is A, that's V minus U over T, and the unit is meters per second squared. Keep a little, focus here. It is squared. For velocities, for speed, it was not squared. It was only meters per second. Do you guys get this?
Yes.
Now, if someone writes, define acceleration, and the answer comes as like acceleration is rate of change of speed. So would that be correct?
No.
So the answer to this is no, not at all. Because when you say if acceleration is only rate of change of speed, then you're missing what part? You're missing the direction part of the velocity. So many of the students, while defining acceleration, they just consider speed. So even if speed is not changing, even only if direction is changing, we can have acceleration. Earth is having acceleration. Fan blades are having acceleration right now. It isn't because they have a change in speed. It is because they have change in direction, which is causing change in velocity. So this is incorrect to say. This is very wrong to say. Do you get this?
Yes.
So I'm going to share these slides with you guys on the WhatsApp group, and I'm going to send you a worksheet, a few questions related to these things, whatever we have discussed. And let's, see how many questions do you guys get correct, right? So while I, send the file of the questions, I would want you guys to review this. So, you don't have to lose marks over it again. So you can have, a very good review alongside some practice questions. So I'm sharing these slides on your WhatsApp group. Did you guys get it?
Not yet.
Do you guys get it now?
Yes.
So your worksheet is coming up. So have you guys reviewed it? Do you have any questions? Do you have any doubts?
No.
Okay, so what are we going to do now is to send you the questions on your group, and then you attempt it, and then we'll see your score, right? So did you got the file? I've shared it on the WhatsApp group. You guys got the file?
Yes, I got.
Yes.
So you'll have 15 minutes to do it, okay? Then we'll start discussing it, okay?
Sir, I have completed the work.
Completed the worksheet. What about the other person? Both of you have done? I have answers from Teresa.
Sir,
Adisa,
I'm
yeah,
sending you the pictures.
yeah. Can you make a PDF?
Okay, I'll make it and I'm sending you.
So, distance, attraction. Okay, okay. Okay, I have reviewed your answers. Let's see what are the correct answers. So, Parisa, yours are correct so far. Adisa, which school are you from?
Sir, I've sent you the PDF
Yeah,
on
I'm
WhatsApp.
asking. I'm asking which school are you from?
I'm in St. Anthony's.
Sorry, come again.
St. Anthony's.
And which city do you belong to? Are you from Karachi?
I'm from Lahore.
You're from Lahore. How's the weather there? Parisa is from Islamabad. So your answer to first question is 16.67. That's very good. That's then you have 48 kilometers is the distance. This is the other answer is also fine. The last answer is also fine. That's nice. That's nice. Good job. Nice. Very good. So both of your answers, you have done a great job. I'm going to send the marking scheme anyways, because if you want to compare, how would I do it? So you have my script as well. Okay. So you'll have this. That's enough. The other part of today's lesson will be around, understanding graphs. So, and that is what is going to be asked in exam. The questions so far we did, I personally haven't ever seen those questions in P2s. They might be asked in P1, that's MCQs, but it is very rare, you know, that examiner asks these kind of questions in P2. That's very surface, very simple. Now, the other thing you might would see in past papers, which we will do definitely, and there is a lot of past papers for kinematics and motion. That is, the examiner will use these terms: instantaneous, or kind of average speed, or average acceleration. These are some of the common terms which examiner would use. So instantaneous, speed or acceleration, or simple speed or acceleration, is exactly same. So you don't have to worry about what is instantaneous speed and what is instantaneous acceleration. You might have never heard about it. We just heard about the speed and we just heard about the acceleration. So it is the same thing. If the question asks you to find out instantaneous speed or if the question asks you to find out the speed, it's the same thing. Now, what is average speed? Average speed would always be calculated using the formula that's total distance over total time. So that's something other than what the speed is. So say, there is a scenario where it says a car travels 100 meters in 2 seconds, right? So the question might say calculate a speed. So what's the speed? So that's 50 meters per second. That's the speed, right? It can also say what's the instantaneous speed. So that's still 50 meters per second, right? And if it says it's, for this question, average speed, so there is no possibility of this average speed because there is only one part of the journey that's discussed, right? It says a car that travels 100 meters in 2 seconds. So that's it. There is no more information. So we cannot actually have average speed here. But if the examiner says, the question continues, then it travels next 200 meters for 4 seconds. Now you'll see that there are two parts of the journey. You can very much understand from this question. So the first 100 meters the car traveled with a speed in 2 seconds. So we have a different speed altogether. For the next part of the journey, that's 200 over 4 seconds. So let's do it. 200 divided by 4. So that's again 50 meters per second, right? So that's the other part of the journey. So if I label this, so that's speed. If I label this, that's speed. So what's the average speed? So it is not calculated by, just taking 50 plus 50 and dividing it with, to the usual mathematical average. No, you don't have to do it. What you have to do is to use the equation I have written. So just use that equation. What's the equation that I've written? What do you see here? That says total distance. So what's the total distance? So first part of the journey was 100 meters. Next part of the journey was 200 meters. So what's the total distance? That's 300 meters. What's the total time for it? So that's 4 and, plus 2. That's 6 seconds. So this is 50 meters per second. So now you can say, sir, what's the difference? If we could have done 50 plus 50 over 2, we still would end up with 50 meters per second. And you're using the same equation and you're getting the same answer. So what's the difference? So the question I created was a symmetrical question. But in exams, you might have a different question altogether. Now, what you could expect in an exam? So a question like this: a bike covers 10 meters in 1 minute to point A. Then the remaining 80 meters in 5 minutes to point B. So you can clearly see this is, another kind of a question. So if I ask you, what's the average speed of the bike? So how you should go? Total distance, that's 10 meters, and 80 meters, that's 90 meters. Total time, that's 1 minute plus 5 minutes, that's 6 minutes. So that's 6 into 60. So your answer to this would be 90 divided by 6 into 60. That's 360. So 90 divided by 360 is 0.25 meters per second. Do you guys get this part?
Yes.
Now, if I ask you, what's the speed or instantaneous speed for first part of the journey to point A? Let's say that's the other question. So what's your answer to this? This would be 10 divided by 1 into 60, right? So that's 10 divided by 60. This would be 0.1666. So let's round it out to 17. meters per second. That's the instantaneous speed to point A. Now, if same could be done for point B, what's the instantaneous speed for B? So how would we do this? So that's 80 divided by 5 into 60. That's 300. So 80 divided by 300 is 0.26, right? Now, if you take average of these two, 0.17 and 0.26, this is not going to be this. That's what the examiner is going to ask. Do you guys get this part?
Yes.
Both of you?
Yeah.
Nice. Now, so how are you guys doing so far? Do you want me to continue with one more hour? Would you be able to absorb all of the questions and instructions, or you want me to, stop here and maybe align a new session during the other week because I have to compensate for 1 hour? So if you guys are, enjoying, if you guys have, the capacity, so we can continue for 1 more hour. If you want me to stop, and if you think that, it's too much for today, then we can stop here and then we can plan 1 more hour during the week, next week, before weekend. What do you guys suggest? I have answer from Adessa. What about you, Parisa? Acha, chalo. So we stop here and we'll continue in the next week before the weekend for 1 hour. Okay. Before that, you try to review these questions, review these slides, and kind of revise it before the other session. Okay, because kinematics or this motion is very important for your physics exam. Okay. Take care. See you guys in the next class. Allah Hafiz.